Okay, students of trigonometry, we're going to look at the last part of this section. And one of the things you may have noticed is there's times when a trig function's negative, there's times when it's positive, and we've seen there's times when it's undefined. So we want to have a strategy for kind of quickly and easily figuring that out. And that's one of the things I'm going to try to show you here. And it all comes back to the definition. Again, trigonometry, a lot of times students think, wow, I have to memorize so much stuff. The best way to learn math is not just blindly memorizing, but understanding definitions and being able to figure stuff out. It's one of the things that I like about math. I always felt like in a class I didn't have to memorize stuff. I could just figure it all out if I understood it good enough, that is. So what we can begin to look at is you have these two definitions. You've got the sine is y over r and the cosecant's r over y. So they have their ratios depend on r and y. So they should be positive and negative in the same quadrants. Okay, so basically I think of it this way. The whole key thing is r is always positive. And since r is positive, then what you have to worry about is just y. This is all about the y value. So if y is positive, then these two trig functions are positive. And if you think about the way quadrants go, if you're up in quadrant 1, you're going to have a positive x and you're going to have a positive y. If you're in quadrant 2, you're going to have a negative x and a positive y. So that means that you're going to end up having a positive sine and cosine in quadrant 1 and quadrant 2. Or not cosine, cosecant. Okay? We're going to be negative when y is negative. So that would happen down in quadrant 4. You would have a positive x and a negative y. And down in quadrant 3, you would have a negative x and a negative y. So you're going to end up being negative in quadrant 3 and 4. So when I think of a sine and cosecant, I just think about the y value. And y is positive up, quadrant 1 and 2. Y is negative down, quadrant 3 and 4. So if I need to know where the sine and cosecant are positive and negative, I can just think about the y value. Okay? All right. So now we'll go on and we'll look at the cosine. Okay, you can reason this out. The cosine and secant both have r and they both have x in it. Okay, r is always positive. That's the key. So what you're thinking about when you're thinking about a cosine is it's all about x. So if you're in quadrant 1 and if you're in quadrant 4, you have a positive x and a positive y. If you're in quadrant 4, you have a positive x and a negative y. So what you're going to find is the cosine and secant will be positive in quadrants 1 and 4 because that's when x is positive. That's how you figure that out. Okay, then if you want to figure out where it's negative, well, you got quadrant 2. You would have a negative x and a positive y, so you're going to have a negative cosine and secant. And then if you're in quadrant 3, you're going to have a negative x and a negative y, so you're also going to have a negative cosine and a negative secant. So I look at this diagram and I just think, okay, cosine is all about x. X is positive to the right. X is negative to the left. That's how I quickly figure out in my mind how these go, these signs go. There's other ways to learn this, but this is a good way to be able to reason this out. Okay, all right. One more. Let's look at the tangent and the cotangent. Okay, now the cotangent and tangent have x and y in it. R is positive, so it doesn't really matter. This doesn't depend on R. So what you're going to find is you're going to be positive where x and y have the same sign, and you're going to be negative where x and y have opposite signs. Okay, so if you kind of look at this and the way this would work, again, quadrant 1, you have a positive x and a positive y. Quadrant 2, you have a negative x and a positive y. Quadrant 3, you have negative x, negative y. And quadrant 4, you have positive x and negative y. So what's going to happen on this is if they have the same sign, you're going to be positive. Okay, because if you did a positive over a positive when you're doing y over x or x over y, you'd get positive. And over here, if you did a negative over negative, you would get a positive. So quadrant 1 and 3 is going to be where the tangent and cotangent are positive. They're going to be negative where you have opposite signs. So like if you did the ratio here in quadrant 2, positive over negative would give negative, and over here, negative over positive would give negative. Okay, so that's how I think of tangent and cotangent. It's just they are positive where the signs are the same. And that's quadrant 1 and 3. Okay, so that's one way to kind of look at that. We're going to be a little bit more formal with this. And this is kind of a quick way to kind of think about this, and I can show you a few other things then. If you're in quadrant 1, everything is positive. Okay, and that would mean that all of the trig functions have positive values. Okay, if you get to quadrant 2, x is negative, y is positive, r is always positive. So you got to think about what's positive. Well, y is positive here. So you would be basically anything that had to do with y and r would be positive. And the only trig function that has to do with that is the sine of theta. So the sine is going to be positive there. Every other trig function has to do with x and y. So all the other trig functions are going to be negative. You go to quadrant 3, you have a negative x, a negative y, and a positive r. Well, what's going to happen on this one is the cosine will be negative because the cosine depends on x, and so does the secant. The sine and cosecant depend on y, so they will be negative. The one that's going to be positive is the tangent. Okay, like that. So that's how that goes. All right. And then go to quadrant 4, you have a positive x, you have a negative y, and a positive r. Well, the one that's going to be positive is the trig functions that depend on x. Those two functions are the cosine and the secant. Okay, so this kind of shows that there's a little statement that I've always seen teachers teach, and you see this if you Google it and stuff like this. This is another quick way to kind of remember this, is this statement, all students take calculus. Okay, so what this really means is it really means the all stands for quadrant 1. Every single trig function is positive in quadrant 1. Okay, the student stands for sine. Okay, so the sine and cosecant are positive because they're reciprocals. Everything else is negative. The take in take calculus means the tangent. So tangent and cotangent are positive. Everything else is negative. Quadrant 4, you have the calculus, which is the cosine. So cosine and secant are positive. Everything else is negative. Okay, a student one time told me she remembers it this way, which I thought was kind of funny. And we're all adults here. She said all strippers take cash. Okay, so I still remember a student telling me that one time. Okay, whatever. Okay, so you find a way that works for you. Okay, all right. So I've always seen that all students take calculus. If you want to come up with something yourself and you come up with something funny, let me know. All right, next page, we're going to kind of utilize some of this information. And what we're doing on this is an exercise to help you kind of reason certain things out in trigonometry. A lot of times in math, you do exercises to help you learn concepts. It's not really an application, it's an educational tool to help you learn things. As a musician and guitar player, there's lots of things that I do that develop my skill. Instead of just playing songs, I might do scales and exercises. Okay, so this one, first of all, what I like to kind of do in this problem is we can start off by, we're given one trig function. We're given that the cosine of t is equal to 5 over 13. And the definition of a cosine is x over r. So this is actually giving you those two values, and that means that one thing we would have to do is we'd have to find y. Okay, well, the other thing is we're in quadrant 4. So if we're in quadrant 4, x is positive, y is negative, and r is always positive. So what you're going to find on this problem is the cosine was already given as positive. If you want to do the all students take calculus, I was about to say all students take cash. So if you do this, you're going to have in quadrant 4, the cosine is the one that's positive and it's reciprocal. So you're going to have a positive there. Everything else will be negative. So if you want to use that statement to remember that, you can do that. So now what we need to do is just do x squared plus y squared equals r squared. And you may know this is a Pythagorean triple. If you do, you save time. So that would be 5 squared plus y squared equals 13 squared. So that would be 25 plus y squared equals 169. If you subtract 25 from both sides, you'll get y squared equals 144. Then you can square root both sides to get that, to get it y equals 12. So essentially what you really have is you have x equals 5. Y technically is negative 12 because you're in quadrant 4. Okay, you may remember in college algebra, you're kind of, when you solve an equation of this type, you're used to putting a plus minus in there. Well, when you're dealing with trig functions, y could be negative or it could be positive. You have to reason out which one it is. And then r is 13. So now we're able to kind of easily write our ratios. So the sine's y over r, cosecant is r over y. So that means our answer would be, for sine, would be negative 12 over 13. Cosecant would be the reciprocal, so that's negative 13 over 12. The tangent is going to be y over x, so that will be negative 12 over 5. The cotangent is the reciprocal, x over y, so that will give negative 5 over 12. Okay, and then the secants r over x, or you could just do the reciprocal of 5/13, so you get 13 over 5. Okay, so that's how you need to do that. When you're given one trig function, you always have the ability to find two of the variables x, y, and r. If I give you a quadrant, then you can figure out whether each trig function is negative or positive. If I don't give you a quadrant, then technically you could not figure out the signs of anything except the secant. You know, that's the reason I'm given a quadrant on that. Okay, so in that particular problem, we found x was 5, y was negative 12, r is 13. And that's what it's all about. X, y, and r is what you totally focus on when you're dealing with finding the values of trig functions. Okay, the next one, what we have is, it looks like we're given a tangent, and we give that we're in quadrant 3. Okay, so I'll kind of start this off the same way. If I'm given tangent of an angle theta is 2 over 3, the definition of a tangent is y over x. So at first glance, it looks like y is 2 and x is 3, but that's not really correct because you're in quadrant 3. If you're in quadrant 3, then it works this way. X is negative, y is negative, and r is positive. So technically, what you would have here is x would be negative 3, y would be negative 2, and then that would leave us with figuring out what r is, which would come from the Pythagorean theorem. Okay, so I'll go ahead and do that. I've got r squared equals x squared plus y squared. That will give r squared equals 9 plus 4. That gives r squared equals 13. And remember, you know, you don't have to really put the plus minus because r is always positive. So r is going to be square root of 13. Okay, so we have that. Now what I'm going to do is just, again, I'll just do the all students take calculus. And in this case, if we're in quadrant 3, the tangent is the one that's positive. The tangent and cotangent are positive. Everything else is going to be negative. Okay, so you could do that, or now that we've reasoned this out, we can just put in our ratios now. So again, the sine's y over r, cosecant is r over y, so now we can formulate our ratios. So the sine would be negative 2 over square root of 13. The cosecant would be negative square root of 13 over 2. And then the secant is x over r, so the secant would be negative 3 over square root of 13. The cosine would be the reciprocal, and then the cotangent's x over y. And notice on this, if you do x over y, you get negative 3 over negative 2. That's why you're getting a positive value anyway. Okay, so that's how that works out. Okay, so those are good exercises. It's a matter of finding x, y, and r. And if you know the trig definitions, nothing to it. And Pythagorean theorem is a part of that too, to find that missing variable. Okay, so let's move to the next place. And to finish up this video and this section, 2 problems are anxiously awaiting you. So work those out, pause the video, come back when you're done and see if you got them right. Okay, why don't you go ahead and check your answers and see if you got all these things right. So the first one was in quadrant 1, and quadrant 1 just means everything is positive. That's the all in all students take calculus. So we have that, and basically the secant's definitions are over x, so that means you know that r is 5 and x is 2. Use the Pythagorean theorem to find y. Y will be positive square root of 21, and the rest of it is writing in those ratios. And you don't have to rationalize denominators. That's not necessary unless you're doing homework and the directions to the problem suggest that you do that. You don't have to. No law of the universe that says thou shalt rationalize denominators. There are times when it's very useful, though. Okay, so the next one, you were given quadrant 4. If you're in quadrant 4, you have a positive x, a negative y, and a positive r. R is always positive. So from the definition, the sign is y over r. So that means y would be negative 7. And that negative, I kind of wrote it right in front of the fraction bar on purpose to make sure that you reasoned out that it was the y value that was negative, not the r value, because r is always positive. So we got that, we got y and r, and then use the Pythagorean theorem. You get a Pythagorean triple, so x would be positive 24. And again, once you find x, y, and r, and if you know your definitions, you just put them in the ratios, and then you got it. Okay, that will wrap us up for that. Really a long section, 6.5, but it's got really so many fundamental things to trigonometry. So I hope this helped, and good luck when you're doing your problems. Let me know if you have questions.